Hello, you're very welcome to this video. I'm Seamus Bellew at Dundalk Institute of Technology, and I'd like to welcome back all our second year electronics students. All much wiser and knowledgeable now, of course. This video introduces matrices as part of the module called a mathematical analysis. So, as we said, this video is an introduction to matrices. So more than one or a group of them is called matrices. But if you've got a single one, it's called a matrix. That's got its root in Latin. So a matrix is a rectangle or a square of numbers. So in this particular example here, we have got 8 numbers in the rectangle. We've got 2 rows, 4 numbers in each row, and we've got 4 columns, 2 numbers in each column. Now, the idea of rows and columns is going to be important for matrices. So as we said, here is row 1. So row 1 of that matrix has 4 numbers, 2, 3, 5, and 7. Likewise, row 2 has got 4 numbers, 8, 9, minus 1, and 0. So row 1, row 2. The matrix also has got columns, so like pillars when you look down the ways. So that's column 1, and there are 2 numbers in the column, 2 and 8. So that's column 1. Likewise, column 2, and then we have column 3 and column 4. So the idea of rows going across and columns like pillars, that's going to be very important, as we'll see. We can also give the matrix a name, so very simple, like a letter. So for example, B equals this matrix, and this matrix has got 3 rows, and there's row 3 shown there in the box. It's also got 3 columns, and there's column 2 shown in that box there. So we can use matrices to do a lot of things in relation engineering. We can solve systems of equations, e.g. Kirchhoff's law, or we can rotate points, or we can perform robotic operations. Matrices can be used to store information. So for example, a bit like a spreadsheet, you have rows and columns on a spreadsheet. So this very simple example here, it mightn't be totally realistic, but it contains the information pertaining to the price of various cars and the various kinds of models. So for example, a Ford 2-door costs 12 grand, a Ford 4-door is 15 grand, and a Ford 5-door is 17 grand. And likewise for the various models in Toyota, 11 grand, 14 grand, and the 5-door Toyota is 16 grand. So we're interested in looking at some of the operations that we can do on matrices. So the first operation is the addition of 2 matrices. And in order to add matrices, they have to be the same size. So that's a rectangle of 6 numbers, a rectangle of 6 numbers. If they were different shape rectangles, we couldn't add them. So that's 2 rows and 3 columns. So we call A a 2 by 3 matrix. Likewise, B has got 2 rows, 3 columns. So B is a 2 by 3 matrix. So we can add those matrices. And it's very intuitive how we'll add them. We add what we call the corresponding entries. So we'll add 1 with 2, that'll give us 3. We add 0 with minus 1, that'll give us minus 1. Minus 7 with 5, and so on. So A plus B equals, and as we said, we have 3 minus 1 minus 2. Likewise, 6 and 3 is 9. 2 and 8 is 10. Minus 3 and minus 4 is minus 7. Likewise, second operation is that we can multiply a matrix by a scalar or a number. So in this case, we're going to do 5A. So we multiply each of the entries in A by 5. So it's 5 times each of those numbers. 5 ones are 5, 5 by 0. 5 by minus 7 is minus 35. And likewise, 5 by each of those numbers there in turn give us 30, 10, and minus 15. And we can combine these operations. So taking a different example now, if this is the matrix A, That's a 2 by 2 matrix. It's got 2 rows and 2 columns. Likewise, B. So what is 2A plus 3B? So 2 times matrix A plus 3 times matrix B. So if we break down the operation just to make life easy for the minute, what's 2A? So multiply each number in A by 2. So we get 4, 14, minus 2, and 12. 4, 14, minus 2, and 12. And what's 3B? 3 times those numbers there. So we get minus 12, 9, 0, and 15. So now we know what 2A is, and we know what 3B is. So what's 2A plus 3B? We just add these numbers now. 4 and minus 12 will give us minus 8. 14 and 9 will give us 23, and so on. And there you go. Likewise, minus 2 and 0 gives us minus 2. 12 and 15 gives us 27. So 2A plus 3B is equal to that matrix there. Multiplication of matrices, a very important operation. Now this is new for some people, and we'll take our time, and it's important to get the key idea. So in order to multiply two matrices, we concentrate on the rows of the first matrix, in this case matrix A. We concentrate on the row, that's row 1, row 2, and we concentrate on columns on the second matrix. So to multiply matrices, we multiply the rows of A by the columns of B. Again, just to say, we multiply the rows of A by the columns of B. So there's row 1 of A, just to highlight it. There's row 2 of A, and there's column 1 of B. So how do we multiply a row by a column? So just for summary purposes, we've got row 1 in matrix A, we've got row 2 in matrix A, and we've got column 1 in matrix B. So what we're going to do is we're going to multiply row 1 by column 1, and that's going to give us a single number that we call row 1 times column 1. And then we come down to the second row and we multiply row 2 by column 1, and that's going to give us row 2 by column 1. So just two single numbers in the final matrix when we do our calculation. So again, to summarize, we multiply row 1, those two numbers, by column 1, those two numbers. And then we multiply row 2, those two numbers there, by column 1, those two numbers. So let's make a start. So how do we multiply row 1 by column 1? Now you notice I've blanked out row 2 for the moment. Let's just concentrate on row 1. So it's row 1 by column 1. And as you'll see, all we do is we multiply the first number in the row by the first number in the column. Then we multiply the second number in the row by the second number in the column, and we add them up. So here we go. So what's row 1 by column 1? So it's 1 by 5, 1 by 5, plus 4 by minus 4. So that's 5 and minus 16 gives us minus 11. So to multiply a row by a column, all you do is you multiply the first number in each. So the first number in the row by the first number in the column, plus multiply the second number by the second number in the column. And as you'll see later on, sometimes we might have three numbers in that row, and we might have three numbers in the column. And we just do the same operation, multiply the first number in each, plus multiply the second number in each, plus multiply the third number in each, and so on. And now we multiply row 2 by column 1. And what's row 2 by column 1? Again, the first number in each, minus 2 by 5, plus 3 by minus 4. That gives us minus 10, and minus 12 is minus 22. So summarizing our information then, when we did row 1 by column 1, we got minus 11. That's it there in pen, not quite as clear. And then we multiplied row 2 by column 1, and we got minus 22. And we can write out our final answer then, AB equals minus 11 minus 22. So that's the original number that we said was going to become row 1 by column 1, single number minus 11. So row 1 by column 1 giving minus 11. Row 2 by column 1 gave us minus 22, and there's the minus 22. So here's how the operation would look without the detail. So we multiply row 1 by column 1, row 1, column 1, and that's row 1 by column 1 there. And then we did row 2 by column 1, and there it is there, and that's our final answer. Okay, example 2. Now you notice the second matrix has got 2 columns. So we multiply row 1 by column 1, row 1, column 2, and likewise with row 2. So again, just to highlight, we've got row 1, row 2. We'll concentrate always on rows in the first, columns on the second. So it's a bit like you stay on the row 1 level first. So you could have several columns going along there. You could have 10 columns. So what you do is you multiply row 1 by as many columns as you have. So you stay on the row 1 level. So it's row 1 by column 1 giving a single number. Then it's row 1 by column 2 giving a single number. If you had a column 3 and so on going across there. Then it's row 2 by column 1, row 2 by column 2. So they're 4 separate numbers. And now you know how to multiply a row by a column. So let's do it for this example. So again, I've taken away row 2 and column 2 for the moment. Let's just concentrate on the row that we're multiplying by the column. So row 1 by column 1. First number in each, multiply them. Second number in each, multiply them, and then add them up. So row 1, column 1, 1 by 5 plus 4 by minus 4 gives us minus 11. We had those numbers already. And then we do row 1 by column 2. So what's row 1 by column 2? Again, the first number in each, second number in each. So it's 1 by 6, 6 plus 4 by 7 is 28. And that gives us 34. So that summarizes row 1 by column 1, row 1 by column 2. So that's minus 11 for that one there and 34 for that one. Then moving down to the next level, down to row 2, likewise we do row 2 by column 1. So minus 2 by 5 and 3 by minus 4. So it's minus 10 and minus 12 gives us minus 22. And then we do row 2 by column 2. So there's row 2 by column 2. Minus 2 by 6 is 12. 3 by 7 is 20. Minus 2 by 6 is minus 12. Plus 21 gives us 9. So we have 11, 34, minus 22, and 9. So let's just see how that looks now. So there you go. The writing is a little bit messy there, but you can kind of have followed it in the previous slide. So our final answer is AB equals minus 11, 34, minus 22, and 9. Example 3. This time we ask the question, can we multiply these two matrices together? Well, the fact that we're asking the question suggests that maybe not. Let's just look at what we have. So here's matrix A, we call it. We've got row 1 and row 2. So we concentrate on rows in the first matrix. And here's matrix B, if we call it that. And it's got 2 columns, column 1, column 2. Now what happens if you try to multiply row 1 by column 1? What do you notice this time? There are 3 numbers in that row and there are only 2 numbers in the column. So you can't multiply each of the corresponding entries. You can do the 7 by the 5, you can do the 8 by the 4, but there isn't a number to match the minus 1. So those matrices are incompatible for multiplication. So we can't multiply them. Let's just summarize the description of those matrices. This matrix here, matrix A, has got 2 rows. So we say it's got a 2 and it's got 3 columns. So it's a 2 by 3 matrix. So that matrix there is a 2 by 3 matrix. 2 rows, 3 columns. This matrix here is a 2 row matrix and 2 columns. So that's a 2 by 2 matrix. And if you notice, that 3 is different from that 2. Usually those 2 numbers need to be the same in order to multiply them. So in this particular example, we can't multiply the matrices. Example 4. Now, these matrices have different shapes, but maybe it's possible to multiply them. Well, you can kind of see that's row 1 by column 1, and there's 3 numbers in each. So we're good for business. We can multiply them, so that's okay. That matrix there is a 2 by 3 matrix. I didn't write it out. 2 by 3. And what kind of a matrix is this? It's a 3 by 2. It's got 3 rows, 3 by 2. So the 3 there matches the 3 there. So those 3 numbers match those 3 numbers. So it's going to be row 1 by column 1, row 1, column 2, and likewise with row 2. So this time, how do we multiply the row by the column? Again, we take away row 2 and column 2 for the minute. Just concentrate on the row. So maybe it's a good idea for you when you're doing these, just concentrate on the row that you're thinking about. Cover up the other rows if you want. So multiply the first number in each, second number in each, and this time we've got a third number in each. So it's 2 by 1 is 2, 3 by 7, 21, 4 by minus 2 is minus 8, and add all that up and we get 15. Likewise, row 1 by column 2, 2 by 0, 3 by 9, 27, 4 by minus 6, minus 24, add them all up and we get 3. So 15 is row 1, column 1, the 3 is row 1, column 2, and now we're finished with that level, and we're going to move down to the next level, row 2, and they'll be down there on the second row level. So row 2 by column 1, and you can kind of see how that operates. 5 by 1 plus minus 1 by 7 plus 0 by minus 2, and that gives us 5 and minus 7 is minus 2. Likewise, row 2 by column 2. 5 by 0 is 0, minus 1 by 9 is minus 9, 0 by minus 6 is 0, and we end up getting minus 9. So minus 2 is that one there, row 2, column 1, and minus 9 is row 2, column 2. And then this here is just a summary of how we piece it together. So 15 is row 1, column 1, 3 is row 1, column 2, and likewise minus 2 and minus 9 slot in there, and there's the final answer. Okay, example 5. We switch the matrices around. So if we asked you to find BA, you might be tempted to think that BA is the same as AB. In numbers it is. If you have two numbers, 2 times 5 is the same as 5 times 2. But not for matrices. If you change the order of the matrices, you get different answers. So in this case here, we've got B by A. So can we multiply B by A? Example 6, another kind of strange combination there. And example 7. You might want to pause the video for a minute and have a go and see can you work out the multiplication of those 3 matrices. So we'll proceed on and we'll have a look at example 5. So again, if we just concentrate on row 1 of the first matrix by column 1 of the second. So how do you do row 1 by column 1? You're used to the idea now. So 1 by 2, 0 by 5, that gives 15. Row 1 by column 2, 1 by 3, 0 by minus 1 gives 3, and 1 by 4 and 0 by 0 gives 4. So that's row 1 by those 3 columns. If you had more columns, you just keep going on. Then you move down to the second level. So let's bring the row 2 in. And row 2 is 7, 9. Likewise, 7 and 9 by 2 and 5. So 7 by 2, 9 by 5. And that gave 59. Likewise, row 1, column 2 gave us 12. So just check that detail out. And row 2 by column 3 gave 28 and 0. And that gave us 28 as the answer. And finally, row 3 by the 3 columns. And you can check that detail out there. So we get minus 34, 0, and minus 8. So where did that 0 come from? Just check that 0. Row 3 by column 2. Row 3, column 2. Minus 2 by 3 gave us minus 6. And minus 6 by minus 1 gave us plus 6. And minus 6 and plus 6 gave us 0. And again, summarizing the detail, we get the 3 by 3 matrix. So we have 3 numbers. We've row 1 has 3 numbers now in the final answer, and there's 3 columns as well. So just tabulating all those answers into the final matrix. So the matrix BA is equal to that matrix, and that was different from the matrix AB. Now, example 6. We've got row 1 by column 1. So you might think this is a little bit strange. So what happens, you multiply row 1 by column 1, you're going to end up with a single number. So how do you multiply row 1 by column 1? 2 by 6, minus 5 by minus 7, and 1 by 0. So that gives us 12, plus 35 is 47, and 0 is 47. So we end up with a single answer, and there you go. You have a matrix with a single number. So multiply row 1 that it got 3 numbers. That was, what kind of a matrix is that there? It's a 1 by 3 matrix. It's got 1 row and 3 columns. So it's a 1 by 3 matrix. And what kind of a matrix is this here? It's a 3 by 1 matrix. It's got 3 rows and 1 column. So it's a 1 by 3, and then it was a 3 by 1. And notice the answer. What kind of a matrix is the answer in the end? It's a 1 by 1. So the two outer numbers give you the size of the final matrix. Example 7. What happens when we multiply these two matrices? What kind of a matrix is that first one there? It's a 3 by 1. 3 by 1. 3 rows, 1 column. And what kind of a matrix is this? It's a 1 by 3. So because that's a 3 by 1 and that's a 1 by 3, we can multiply them. And we're going to end up getting a 3 by 3 matrix. And that's a bit strange looking, but how does it work? We do row 1 by column 1. There's only a single number in each this time. So it'll be 6 by 2. Then you do row 1 by column 2. That'll give us minus 10. And we do row 1 by column 3. And that gives us 6. So slightly different setup this time. So let's just highlight the rows. We got row 1, row 2, row 3. And each of the rows have only got one number this time. We've got column 1, column 2, column 3. And again, each column has only got one number. So very quickly then, how do you do row 1 by column 1? There's only the first entry in the row by the first entry in the column. So it's straightforward. 6 times 2 is equal to 12. Row 1 by column 2, 6 by minus 5, minus 30. Row 1, column 3, 6 by 1 is 6. Likewise with row 2, you multiply minus 7 by each of those numbers in turn. So we get minus 14 plus 35 and minus 7. Row 3 by each of the columns, and it's 0, and 0 by all those numbers there are going to give you 0 each time. So that's how our final matrix looks. So just kind of check one of those again. Row 2 by column 1 gave us minus 7 by 2, giving us minus 14. So we hope you found this video helpful, and we look forward to seeing you the next time. Thank you very much.